In this scenario, we are going to be taking a look at a game that was created for like a charity fair where they're going to try and raise some money by offering people a chance to play this game. They're calling it Lucky Dip. And it says each barrel contains an equal number of red, green, white, and black balls. The balls are buried in sawdust so that you cannot see them before you pick one out. To play the game, you give Anne, I'm guessing this is Anne here, your 25 cents, and then you pick one ball from each barrel. You win $5 if all three balls are the same color. So we don't know how many balls are in each barrel, but there's the same number of each color in each barrel. So maybe there's 5 red, 5 green, 5 white, and 5 black in each barrel. Or we don't know exactly, like I said, how many are in each barrel, but there's the same, an equal number. They're split evenly between the 4 colors. So let's take a look at the questions that we have that we're going to be answering for this scenario. It says, first of all, what fraction of the total balls in each barrel are red, green, white, and black, and then explain. So let's start by answering that. Well, it says that they're split evenly, right? An equal number of red, green, white, and black balls, and there's 4 different colors. So the fraction of the total balls that are red would be 1/4. Green would be 1/4. White would be 1/4, and black would be 1/4. Explain, it says that the colors are split evenly, or each barrel contains an equal number. So I'll say each barrel contains the same amount of each color. So if we just take the total amount of balls and split it evenly between the 4 colors, that'd be 1/4, 1/4, 1/4, and 1/4. If there were only 3 colors, then it'd be 1/3, 1/3, and 1/3. If there were 5 colors, it would each color being getting 1/5 of the balls. Since there's 4 colors, each barrel contains 1/4 red, 1/4 green, 1/4 white, 1/4 black. Okay, the next question says, what is the probability of drawing 3 red balls? For instance, a red, and a red. Now, there are a few different ways that we can do this problem. First of all, I'd like to write out kind of like what this question is asking me to say. This is asking me what's the probability of going red, red, and red. Now, one way we could do it is to literally try and diagram out all the possible outcomes of picking your ball from each of the 3 barrels, right? We could say, well, I could pick a red ball first, and then after red, I could get another red, and after red, I can get another red. Or I could do red, green, white, or red, green, black, and I could try and diagram out all the different possibilities of what could happen if I pick out a ball from each of the barrels. But that would take a long time. It would be pretty tedious, and I don't think I want to do that. So instead, what I'm going to do is I'm going to treat these things as 3 independent events. So the probability of picking red, 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 I'm going to calculate that by finding the probability of picking a red out of the first barrel, and the probability of picking a red out of the second barrel, and the probability of picking a red out of the third barrel. And when we're doing probability and we see this word "and" here, that tells us, there's a little hint that you can kind of keep in mind, that tells us that we're going to multiply these 3 probabilities together. If you see "or" in a probability question, that's usually telling you to add, but when you see "and," think multiply. So just a good tip to keep in mind for doing probability questions. So to find the probability of going red, 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 we're going to find the probability of picking a red out of the first barrel, multiply it times the probability of picking a red out of the second barrel, multiply it times the probability of picking a red out of the third barrel. So let's think, what are these different probabilities? Well, I don't know exactly how many balls are in each barrel, right? But I do know that since 1/4 of the balls are red, then my probability of picking a red ball out of the first barrel is 1/4. And it would be 1/4 to pick a ball out of the second barrel that's red, and it'd be 1/4 probability to pick a ball out of the third barrel that's red. So that means I have a total of, if I multiply these 3 fractions together, 1 times 1 times 1 will be my numerator, 4 times 4 times 4 will be my denominator, so 4 times 4 times 4, so that is going to be 1/64. That is my probability of drawing 3 red balls. And I'm just going to leave that as a fraction for this one. I'm not going to convert it to a decimal or a percent because I think as what I'm going to do with some of this later on is it's going to be easier to keep it as a fraction. So I have a 1 in 64 chance of going red, red, and red. Well, how many ways can you win the game? Well, you can win the game by going red, 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 green, 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 white, 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 or black, black, black. Because it says in order to win, you have to have all 3 balls the same color. So how many ways can I win this game? I can win 4 ways. The 4 ways I can win are going red, red, red. I can go green, green, green. I can go white, white, white. Or I can go black, 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 right? Those are the winning combinations of what I could get. So then it says calculate the probability that you will win the $5 if you play once. Okay, so this says find the probability that you do red, 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 or green, 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 or white, 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 or black, black, black. So I would write this way. I would say I'm calculating the probability of I'll say a probability of a win, which is the probability of going red, 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 or green, 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 or white, 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 or black, black, black. And when we see or in probabilities, you should think addition. Addition. So to find the probability of going red, 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 or green, 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 or white, 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 or black, 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 we're going to take the probability of going red, 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 add it to the probability of going green, 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 add that to the probability of white, 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 add that to the probability of black, black, black. Now, what are each of these probabilities? Well, we already calculated the probability of red, red, red as being 1/64th. But the probability of going green, green, green is going to be the same because there's not more green balls or fewer green balls than there are red balls. It's an equal amount of green balls as red balls, as white balls, as black balls. So these are all going to be 1/64th probability. Now, if I add these all up, since I'm adding, I need common denominators, which I have, 64. And I just add the numerators. That's 1 plus 1 plus 1 plus 1. So that's 4/64. Which, I'm running out of space here a little bit, is going to be equal to 1/16. We have a 1 out of 16 chance of winning. So the next question says, do you think that this game is going to raise money for the local charities? Show your work and explain. Well, means that there's a few ways you could look at this. Every time 16 people play the game, they're going to have one winner. Is what this says. That's another way of thinking about what this says. So if the probability of a win equals 1/16, then one way to think about that is for every 16 players, one will win. On average, of course. It's not guaranteed that if 16 players play, only one wins. Maybe nobody wins. Maybe 2 people win. But, you know, the math says that for every 16 players, one is going to win. So what does that mean? Well, if we have 16 people play the game, how much money did we collect? So if we take 16 players and we multiply it times 25 cents, that means that we're going to collect $4. So we collect $4. Amount collected from 16 players. But we only pay out $5, right? 16 players collects $4. $5 will be paid out. Will be paid out. So therefore, the game will raise money because they're going to collect $4. Or sorry, the game will not raise money. Said that wrong, didn't I? The game will not raise money because it will only collect $4, but it will be paying out $5 out of those 16 players on average. Therefore, game will not raise money. So the question 6 says, compute the expected value for the game Lucky Dip. Show your work. Do you think Lucky Dip will raise money for the charity if 100 people play? And explain. Well, we kind of, I guess, already answered that. But let's compute the expected value for the game Lucky Dip. So the way we're going to do this is we're going to look at the probability of winning and the probability of not winning and think about the value of each of those outcomes. So I'm going to do the probability of a win times the value of a win. Now I'm going to look at this as from the perspective of running the Lucky Dip game. So the value, if I'm running this game and somebody wins, that has a value of -5 for me because it means I'm losing $5. The probability of not winning, so we'll say probability of no win, has a value of 25 cents. So 0.25, I'll write that. I'm gaining 25 cents if I'm running this game and the person didn't win. So I'm going to take these two calculations and I'm going to sum them together. I'm going to add them together. So let's look at how this ends up. The probability of winning is 1/16 times -5. I'm just going to write that as -5/16. Probability of not winning, well, if you have a 1 out of 16 chance of winning, then there's a 15 out of 16 chance of not winning. And I'm going to multiply that by 0.25. I'm going to express that 0.25 as 1/4, right? Because that's the fraction version of 0.25. So this means I got 15/64 for that calculation. Now when I do expected value, I take these outcomes times their values, and then I add those two amounts together. So now this now comes to where I'm going to do -15/16 plus, or sorry, -5/16 plus 15/64, or 15/64. So first of all, I need to convert that to a 64 denominator. So I'm going to multiply it by 4 to do that, and then I have to multiply the top times 4. That's a -20/64 plus 15/64. Of course, you could just do that on a calculator by typing in -5/16 plus 15/64. Regardless, I now have -5/64. Now, that's kind of in terms of whatever unit our value is in. So since this is a game about money, this is like in dollars, right? This value is in dollars. So this is in dollars as well, but we don't think about dollars this way very often. Usually we're going to take this -5/64 and we're going to convert that to decimal because that's the way we kind of think of dollars, right? In terms of decimals. So let's convert that to decimals real quick. So I'm literally just going to type in my calculator -5 divided by 64. And this gives me -0.078, which means it's going to lose me about 7.8 cents every time somebody plays this, right? This is a dollar amount. So this means we will lose about 7.8 cents for each player. So then, will the money raise, what will it do for 100 people that play? Well, now if we just multiply that times 100, so if we take 7.8 cents times 100, then that's going to give me, what, about $7.80? So if 100 people play, I'm going to write that down here. Therefore, if 100 people play, we will lose about $7.80. This is coming from 0.078 times 100. That's where I'm getting this $7.80 loss from. I'm losing about 7.8 cents for each player. Multiply that times 100, I'm going to lose about $7.80. Now, the rest of the questions on this handout ask you, okay, well, how do we maybe adjust certain things here to make this game maybe more profitable for the charity fair? The way it's set up, it sounds cool. You don't have a great chance of winning, right? You only have 1 in 16 chance for winning. But if we're going to pay out $5 when they do win, we're going to lose money. So how are we going to adjust this? What kinds of changes will we make to this game to maybe make it actually profitable for the charity fair? And that's what you'll be looking at for the rest of this worksheet.